man in his late 60s stands at his kitchen counter at 7 in the morning, knuckles pale against the lid of a pickle jar, the muscle in his forearm thin as old rope, the lid refusing to move. He sets it down. He waits. Most people in his position blame the jar. They do not blame the slow disappearing of muscle from a body quietly underfed for 30 years. But the geriatric nutritionists who study sarcopenia, the slow wasting of muscle that begins in middle age, have found something that overturns nearly every dietary assumption of the last 50 years. In almost every case, the failing grip is not aging. It is simply protein arithmetic, done in dry weights, on dinner plates that never held the meal advertised. The correction sits in 8 ordinary plants, most of them already in rural pantries, that outdeliver beef on the only measurement that matters, the protein the body can actually absorb and use. 8 of them, to be exact. 8 plants that geriatric nutrition departments at Tufts and Wageningen have quietly studied, that Pennsylvania Dutch and Ozark farm tables have leaned on for generations, and that the meat industry would prefer never enter the muscle loss conversation. There is no patent in a bowl of lentils. This is the story of those 8, what each one does, why each one works faster than the supplement aisle, and the mistake nearly every protein-conscious adult past 45 quietly makes at the dinner table. The grocery aisle has been telling a story for 2 generations. The story says muscle requires meat. The story says protein lives in steaks and chicken breasts and protein bars wrapped in foil. The story is not exactly false. It is simply incomplete in the way that benefits the people selling it. Because protein, measured plainly by what the body absorbs, by the amino acid that triggers muscle to rebuild itself, by the gram per realistic dinner plate serving, does not require an animal. It requires a few specific plants, prepared a few specific ways, eaten with the small wisdom that quietly disappeared from American kitchens somewhere between 1955 and the rise of the freezer aisle. 8 plants follow. Each one carries more usable protein per realistic serving than the meat it replaces. Each one carries a mechanism the supplement industry has spent 40 years either ignoring or distorting. And each one comes with one specific mistake, the mistake that has caused most plant-based protein attempts to fail in households over 45. Plant 1. Pumpkin seeds. The forgotten core of the autumn harvest. What if the most protein-dense seed in the American October was not in a health food store, not in a powder, not in a pill, but sitting in a wet pile beside a cutting board, on its way to the trash, every single year for the last 100 years? 9 grams of protein in a quarter cup, more than an egg. Inside the pale green kernel, cucurbitin, a rare amino acid found almost nowhere else in the food supply, magnesium, in higher concentration than almonds, and zinc, the mineral the immune system and the slow rebuilding of muscle both quietly require, and the mineral most adults past 50 quietly run short on. The geriatric nutrition group at Tufts has flagged zinc shortage as a hidden driver of grip weakness past 60. Pumpkin seeds carry more zinc per ounce than any common meat outside oysters. Muscle protein synthesis depends on amino acids arriving with their cofactors. Protein without zinc is bricks without mortar. The pumpkin seed delivers both in one handful, which is why harvest cultures from Pennsylvania to Oaxaca treated them as winter medicine. The common mistake is buying the seeds already roasted, salted, and held 6 months under fluorescent light. The oils oxidize. A rancid seed loses most of its zinc absorbability. The seed that works is pulled from the squash, dried in a low oven, eaten within a month. Treated as snack food, pumpkin seeds underperform. Treated as a fresh autumn harvest, low oven, sealed jar, eaten through the cold months, they outwork most cuts of meat per calorie consumed. The setup is 3 steps. Scrape the seeds from a pumpkin or butternut squash. Rinse and spread on a sheet pan. Roast at 250 degrees, 45 minutes, until the shells turn the papery color of old sheet music. The signal is the sound. A faint, dry crackle when a kernel is pressed between thumb and finger. The same crackle as a tea bag held a moment too long in hot water. That crackle means the oils are stable, the zinc still present. Eaten daily, a working handful, not a teaspoon, grip markers begin shifting in the second week. By the third, the heaviness in the legs on stairs begins to lift. Picture the same jar 6 weeks forward. The forearm is no thicker, but the small fibres that close a hand around a lid have been quietly fed every afternoon by a quarter cup of pale green kernels. The lid turns, the morning continues. For the household that believed strength left with youth, the pumpkin seed is the smallest correction with the largest return. There is no protein bar made of pumpkin seeds, because there is no margin in a seed that grows free inside a vegetable already in the cart. A pumpkin in October costs $4. The seeds 9 out of 10 households scrape into the trash, would cost $22 at the supplement counter. The trash bag is the most expensive part of the harvest, but pumpkin seeds are seasonal. The next plant sits year-round in a paper bag at any roadside stand from Georgia to Iowa and carries the name of the most underread agronomist in American history. Plant 2. Peanuts. The legume the South already understands. Why did George Washington Carver, a man who could have spent his career on cotton chemistry, on industrial fibre, on the prestigious crops of his time, devote 3 decades and over 300 recipes to the humble peanut? 26 grams of protein in a single cup, as much as 4 ounces of beef. Inside each peanut, arginine, the amino acid most associated with circulation and capillary strength. Niacin, which the metabolism needs to convert protein into actual tissue. And a slow-burning fat profile that keeps the protein landing across hours, not minutes. In 1903, at the Tuskegee Institute in Alabama, Carver published a bulletin titled simply, "How to Grow the Peanut and 105 Ways of Preparing It for Human Consumption." He understood, before the word existed, what modern researchers call protein density per acre. The mechanism is bioavailability. Plant proteins live behind cell walls. Most plants demand cooking, soaking, or grinding before the body can reach the protein. The peanut, lightly roasted, gives up most of its protein at the chewing stage, which is why a handful at 3 in the afternoon steadies the body the way a small meal would. The common mistake is the peanut butter aisle. The jar that lists palm oil, sugar, and hydrogenated something as the second, third, and fourth ingredient is no longer a peanut. It is a candy spread with peanut flavouring. The protein remains, but the metabolism is now processing the additives first. The peanut Carver studied was the whole peanut, shell removed, kernel intact, oils unaltered. The peanut that works the same today is one ingredient on the label. The setup is plain. Buy peanuts roasted in their shells or unsalted dry roasted in a sealed jar. A working portion is 1 handful, twice a day, between meals. The signal is the smell of the paper bag from a roadside stand. Earthy, faintly sweet, with the warm dust of the shell. That smell is the volatile compounds intact. A bag that smells of nothing has lost most of what made it food. Within 10 days of daily inclusion, blood sugar steadiness shifts. Within 3 weeks, the late afternoon energy hollow that drives most adults past 50 toward a second cup of coffee begins to close. Picture an afternoon at 3:30, when the body does not begin to fail. The reading lamp does not need to be moved closer. The book does not begin to slide off the lap. A handful at 1 o'clock has fed the slow muscles of attention, posture, and grip. For the man who has watched his energy disappear by mid-afternoon for 15 years, the peanut is the cheapest possible answer to a problem he was told required medication. Carver's work sits underread in American agricultural history. His insistence that one cheap legume could feed an entire region was inconvenient to the cotton lobby of his era and remains inconvenient to the meat industry of this one. A penny crop fed nations the dollar crops could not. The peanut covers the household kitchen. The next plant covers the dinner plate. A seed once jailed by federal law and only released back into the food supply within recent memory. Plant 3. Hemp seeds. The seed federal law spent 50 years erasing from American kitchens. How does a single tablespoon of a seed grown legally on every continent, eaten by every pre-modern Eurasian people, deliver more complete protein than a slice of chicken breast? 10 grams of protein in 3 tablespoons, with every essential amino acid present. Inside the soft kernel, edestin, a protein structurally close to the proteins in human blood plasma. Gamma-linolenic acid, the rare omega-6 that calms inflammation rather than driving it. And a balance of magnesium, iron and zinc, almost unique in the seed kingdom. Justus von Liebig, the German chemist who founded agricultural nutrition science in the 1840s, identified hemp as one of the most efficient protein crops per acre in the temperate zone. The work sat on shelves while a different agricultural lobby quietly outlawed the plant. The mechanism is structural. Edestin is what biochemists call a complete and bioavailable protein. Its amino acid profile mirrors what human muscle is actually made of. Most plants force the body to assemble protein from incomplete materials. Hemp delivers it pre-assembled, without the saturated fat, without the slow digestion. The common mistake is treating hemp seed as a topping. A pinch on a salad is a flavor. A working portion is 3 full tablespoons, eaten daily, not weekly. Most adults underdose hemp by a factor of 10 and conclude the seed does not work. The plant does not fail, the portion does. 3 tablespoons in oatmeal, 3 in yogurt, 3 over a bowl of soup. The working dose disappears into ordinary food without changing the taste of the meal. Setup is one step. Buy hulled hemp seeds in a sealed package. Store cold. Spoon 3 tablespoons over the first meal of the day. The signal is the sheen. Hemp seeds release a faint buttery oil when stirred into a warm bowl. The same sheen as a pat of butter just beginning to melt on toast. That sheen is the gamma-linolenic acid intact. Within 2 weeks, the joints begin to feel less stiff in the morning. Within 3 weeks, the inflammation quietly running under the skin of most adults past 50 begins to settle. Picture a morning when the first hour out of bed is no longer a careful negotiation with the knees. Picture an afternoon when the elbow does not ache during the second hour of yard work. Hemp seeds are not a painkiller. Hemp seeds are a slow rebuilding of the tissue the pain was trying to flag. For the household that has spent 2 decades managing inflammation with pills, the hemp seed is the small daily correction nothing in the medicine cabinet can match. Hemp was outlawed in 1937 under the Marijuana Tax Act, championed by Harry J. Anslinger and supported quietly by the cotton, paper, and synthetic fiber industries that competed with the plant. The seed, non-psychoactive, calorically rich, agriculturally efficient, was collateral damage. The seed outlived the law that erased it. Hemp covers protein density. The next plant covers protein execution. 3 preparation methods, one of them sprouted, one fermented, one cooked plain, and carries the answer to every household that has ever tried to eat plant protein and ended up with a stomach in revolt. Plant 4. Lentils, the composite plants that built civilizations. Why has every plant-based protein attempt by adults past 45 hit the same wall? The wall called bloating, gas, and the quiet conclusion that the body is simply rejecting the plan. 18 grams of protein in a cooked cup, with 3 preparation methods that decide whether the bowl heals or punishes. Red lentils, the orange-pink kernel that breaks down quickly into soup, carry the highest lysine content of the common legumes. Lysine is the amino acid most adults eating American breads and grains are short on. A bowl of red lentil dal corrects the day's protein gap in 15 minutes of simmering. Green and brown lentils hold their shape under heat. They carry slightly less lysine but more polyphenols, the dark pigment compounds that calm low-grade joint inflammation. Black beluga lentils carry the highest concentration of antioxidants in the legume family. They cook in 20 minutes and hold their structure in salads. Now, here is a point where much of the common protein advice is simply wrong, and it is worth pausing on. The internet has spent 10 years telling adults that lentils contain anti-nutrients, phytic acid, lectins, oxalates, and therefore should be avoided or feared. The claim is a half-truth, weaponized into a full mistake. Phytic acid binds to minerals only in raw, unsoaked legumes. The traditional preparation that every grandmother in the lentil-eating world has used for 2,000 years neutralizes the binding before the bowl reaches the table. The common mistake is opening a bag of dry lentils, dumping them in a pot, boiling them for 20 minutes, and eating them with rice. That preparation skips the soak. The phytic acid binds calcium, zinc, and iron. The protein arrives, but the cofactors do not. This is the source of every lentil bloat, every disappointing energy result, every household that quietly returned to chicken. When the legs feel heavy on the stairs in the morning, 3 causes compete. 1. Circulation. 2. Vitamin D shortage. 3. The cause almost no one is told about. The body is breaking down its own muscle for amino acids the diet failed to deliver. Lentils, prepared correctly, address only the third. But the third is the cause driving most cases past 55. Setup is 2 days. Soak 1 cup of lentils overnight in cool water with a half teaspoon of baking soda. The baking soda neutralizes the phytic acid. Drain, rinse, and either sprout for 36 hours or simmer with a strip of kombu seaweed for 20 minutes. Both methods triple the bioavailable protein. The signal is the steam. Properly prepared lentils release a clean, earthy steam, the color of wet stone, the smell of clean rain on a barn roof. Lentils that smell sour or starchy were undersoaked. Trust the nose. A working bowl, once daily, with the proper preparation, lifts the energy floor within 2 weeks. Sprouted lentils, eaten cool over salad, work fastest. Picture a kitchen where the bag of dried lentils on the counter is no longer the failed experiment from last spring. The bowl is warm. The body is steady. The afternoon does not collapse at 4. The legume that fed Egyptian masons, Roman legions, and Pennsylvania farmhands is doing the same work it has done for 5,000 years. For the household that gave up on plants because the bloat was worse than the protein gain, the soak is the small correction that rewrites the entire experiment. There is no patent on lentils. There is no industrial supply chain protecting them. A pound of dried lentils costs less than a single rotisserie chicken and feeds a family for 2 days. The protein industry does not want them on the dinner table conversation. Lentils answer the bloat. The next plant answers the most loudly marketed claim in the supplement aisle, the claim that a teaspoon of green algae can replace a steak. Plant 5, spirulina, the dry weight deception that needs correcting. How did a microscopic blue-green algae become the most overpromised protein in the supplement aisle? And what does an honest serving actually deliver? Spirulina is 60 to 70% protein by dry weight. A teaspoon delivers roughly 4 grams. Inside the powder, phycocyanin, the deep blue pigment that gives spirulina its color and carries antioxidant strength comparable to vitamin E, iron in a bioavailable form, and a B12 analog that supports, but does not fully replace, the B12 the body actually requires. The Aztec at Lake Texcoco harvested spirulina from the lake surface long before Europeans arrived. The Kanembu people of Lake Chad still harvest it. The protein content is not in dispute. The serving size in modern marketing is. Phycocyanin is the working compound. It quiets the same inflammatory pathways as the omega-3 fats in fish oil, and it raises iron uptake in adults who are quietly anemic, a condition driving more grip weakness past 60 than the cardiology lobby will mention. The common mistake is the math. The supplement label says 70% protein. The viewer hears, a teaspoon equals a steak. The truth is, a teaspoon weighs 3 grams. 3 grams at 70% equals 2 grams of protein. To match a small chicken breast, the serving would need to be roughly half a cup of raw algae powder, a serving no one alive has ever finished. Spirulina is a protein supporter, not a protein replacer. Used plainly, 1 to 2 teaspoons daily, spirulina fills the iron gap, calms the inflammation gap, and adds 2 to 4 grams of protein to a bowl already carrying lentils, hemp, or pumpkin seeds. Used as a meat replacement, it disappoints every household that tries it. Setup is plain. 1 teaspoon stirred into a glass of water with lemon, or 2 teaspoons mixed into a smoothie with hemp seeds. Once daily, before the first meal. The signal is the colour. Properly stirred spirulina turns the water a deep, opaque blue-green, the colour of a pond in late June. A pale or chalky colour means the powder has aged and the phycocyanin has broken down. Within 4 weeks, the iron-related fatigue begins to lift. The afternoon energy floor rises slowly, not dramatically. Picture a morning when the climb out of bed is not a fog. Spirulina alone does not deliver this. Spirulina paired with lentils, hemp, and pumpkin seeds does. The math, finally, adds up to a plate that feeds the body the way a steak used to. For the households sold on the 70% claim, the correction is not abandonment. The correction is reading the spoon honestly. Spirulina sourcing matters. Lakes near industrial zones can carry heavy metals, lead, arsenic, mercury, that cling to the algae cell wall. Buy from certified clean water harvesters. The price difference is $6. The difference in the body is everything. Spirulina supplements the bowl. The next plant builds the muscle directly and carries the amino acid that decides whether a meal triggers the rebuilding switch or wastes the protein on the way through. Plant 6. Soybeans. The leucine threshold made plain. Why does a bowl of plant protein sometimes still leave the body wasting muscle, even when every essential amino acid is technically present? 28 grams of protein in a cup of cooked soybeans, with the highest plant leucine content on this list. Inside the cooked bean, leucine, the amino acid that signals the body to begin building muscle. Isoflavones, the polyphenols that quietly steady hormones in adults past 50. And a complete amino acid profile that mirrors the proteins in animal muscle. Researchers at the University of Illinois and at McMaster University have spent the last 15 years on a single question. How much leucine in a single meal is needed to actually trigger muscle protein synthesis in adults past 50? The answer is a stable 2.5 to 3 grams. Most plant meals miss it. Soybeans clear it in a single cup. The mechanism is the switch. Muscle cells run a kind of light switch. Leucine flips it on, and only then does the body begin assembling protein into new tissue. Below the threshold, the protein is consumed as fuel. Above it, the body rebuilds. This is why a slice of chicken builds muscle, while a salad with chickpeas often does not, even when the protein numbers look similar on paper. The common mistake is edamame as snack food. A small handful, a few times a week, will not flip the leucine switch. The serving that works is 1 full cup of cooked beans, about 3 handfuls of edamame in the pod, at 1 meal, not spread across the day. Cooked soybeans, dried soy nuts, or a wedge of plain tofu all carry the leucine. Soy isolates and processed soy protein bars carry the leucine plus a long list of additives the metabolism then has to clear. The bean does the work, the factory does not. Setup is 2 options. Buy frozen edamame in the pod, steam for 6 minutes, eat 1 cup of beans. Or simmer dried soybeans for 2 hours and store cooked in the refrigerator. The signal is the pop. A properly cooked edamame pod splits open under thumb pressure, releasing the bean with a clean snap. A pale or limp pod was overcooked or stored too long. Within 2 to 3 weeks of 1 cup daily, grip strength markers begin shifting. The morning fatigue past 60 begins to lift in week 3. Picture an afternoon at 4 when the body has not begun to fail. The leg heaviness on the porch step has eased. The grip on the railing is not a careful negotiation. A bowl of edamame at noon flipped the switch hours ago. For the household that has eaten plant-based for years and watched muscle disappear anyway, the leucine threshold is the missing instruction. The food industry that profits from soy isolates and protein bars has no interest in the plain bean. The bean that costs 80 cents a pound and asks no permission of the supplement counter. Whole soybeans, like whole lentils, sit outside the patent. Soybeans flip the muscle switch. The next plant, controversial, ancient, and made of one ingredient, solves the texture problem that drives most retired men back to red meat. Plant 7. Seitan. Wheat protein, isolated and cooked plain. How does a piece of bread, properly washed, become a slab with the texture, the bite, and 25 grams of protein per serving? The kind of plate that satisfies a man who grew up on Sunday roasts. 25 grams of protein in a 4-ounce serving, as much as a small steak. Seitan is wheat gluten, the elastic protein extracted when flour is mixed with water and rinsed until the starch washes away. What remains? Glutenin and gliadin, the structural proteins that give bread its chew. Buddhist monks in 7th century China developed seitan as a meat substitute during fasting periods. The technique was preserved in temple kitchens for over 1,000 years before reaching American natural food stores in the 1970s. The mechanism is texture. Most plant proteins are powders, kernels, or beans. Seitan, cooked in broth and sliced, behaves like meat in the mouth, and the chewing pattern matters. Slow, deliberate chewing on a substantial protein activates satiety signals that no smoothie ever triggers. The common mistake is treating seitan as universal. Anyone with celiac disease cannot eat it. Anyone with non-celiac gluten sensitivity will feel it within hours. The plant is gluten itself, in concentrated form. The household that thrives on it is the household with no wheat sensitivity at all. Used plainly, seitan is the bridge protein. The plate looks like dinner. The texture satisfies the part of the meal that powders never reach. The body recognizes the chew and begins the digestive cascade meat would have triggered. Setup is 1 hour. Mix 1 cup of vital wheat gluten with 3/4 of a cup of broth. Knead until firm and simmer in seasoned stock for 45 minutes. The slab can be sliced and stored for a week. The signal is the resistance. A properly cooked seitan slab gives under a knife the way a roast does, firm with a slight spring. A spongy or rubbery cut was undersimmered. A dry cut was overbaked. Seitan delivers fast. Protein digestion begins in the stomach within 30 minutes. Within 2 weeks of regular inclusion, the dinner plate satisfaction returns to plant-based meals. Picture a Sunday dinner where the plate carries a sliced loaf of seasoned seitan, a bowl of greens, and a portion of lentils. The protein arithmetic exceeds the roast it replaced. The chewing satisfies the body the way the roast did. For the household that loved Sunday dinner and lost it to dietary restriction, the seitan slab is the texture coming home. Seitan production sits at the boundary between traditional craft and modern industry. Buddhist monasteries still make it by hand. Food processors make it with additives. Read the label. One ingredient is the version that works. Seitan rebuilds the dinner plate. The next plant, older than written agriculture in some traditions, closes the protein conversation entirely. Plant 8. Tempeh. The fermented patty that solved every problem above it. What if the answer to the protein question, the leucine threshold, the bloat barrier, the bioavailability gap, the anti-nutrient warning, sat in a single Javanese kitchen technique 2 centuries before any of these problems had names? 19 grams of protein in a 4-ounce patty, plus the only plant source vitamin K2 most adults will ever encounter. Inside the cake, cooked soybeans, bound and partially digested by the white mycelium of Rhizopus oligosporus. The fungus produces enzymes that break down phytic acid, lectins, and the oligosaccharides responsible for nearly every plant protein digestive complaint. It generates genistein, an isoflavone with bone density benefits, and vitamin K2 in the form of MK7, which directs calcium into bone rather than artery. The earliest written reference to tempeh appears in the Serat Centini, a Javanese manuscript compiled between 1814 and 1823, predating the European discovery of vitamins by roughly a century. Javanese village kitchens were producing a fully bioavailable plant protein with built-in K2 generations before the science existed to explain why their elders held strength into old age. The mechanism is fermentation. The fungus does, in 36 hours, what the human gut spends days struggling with. The phytic acid is gone. The lectins are gone. The carbohydrates that ferment in the gut and produce gas are pre-digested. What arrives at the table is protein the body can absorb without the work, and without the bloat. The common mistake is treating tempeh as tofu. Tofu is a curd. Tempeh is a fermentation. The two have nothing in common except the bean. Tempeh that has been over-frozen, sliced thin, and pan-fried until rubbery has lost most of what made it traditional. Tempeh steamed first, then briefly seared, retains the living enzymes. Used as the centerpiece of one meal a day, tempeh closes the gaps left by every other plant on this list. The leucine is present. The K2 is present. The digestive ease is present. The protein is pre-assembled. Setup is one purchase plus one technique. Buy a fresh tempeh cake from a refrigerated case. Steam for 10 minutes. Slice and sear briefly in a hot pan with broth. The signal is the aroma. Fresh tempeh carries a faint mushroom and walnut smell. Clean, slightly earthy, not sour. A sour or ammonia note means the cake has aged. The aroma of properly fermented tempeh is the aroma of working enzymes. Within 2 weeks of daily inclusion, digestion steadies. Within 4 weeks, the bone density and joint stiffness markers begin shifting in ways the calcium pill never delivered. Picture an evening at the porch when the back does not ache from the small bend of putting on shoes. The morning when the wrist does not crack on the first turn of the doorknob. Tempeh is calcium directed correctly into bone, by a vitamin most multivitamins still skip. The fermentation produces something else. A small population of beneficial gut bacteria pre-colonize the digestive tract before the patty arrives. Tempeh is, quietly, both the protein and the probiotic. For the household that has watched bone density drop, the legs grow heavy, and the gut grow temperamental, all at once, all past 60, the tempeh patty is the one quiet correction that addresses each simultaneously. In Javanese village kitchens, the technique carries names that translate roughly as the slow ferment, the patient transformation. The Javanese understood, through 8 generations before any laboratory existed, that the most useful protein is not the protein with the highest number on a label. The most useful protein is the protein the body can actually open. Patience makes the protein. Patents do not. 8 plants. 8 working answers. The last word belongs to the kitchen. Pumpkin seeds, the autumn harvest. Peanuts, the carver legume. Hemp seeds, the outlawed plant. Lentils, the soaked staple. Spirulina, plainly portioned. Soybeans, leucine strong. Seitan, the wheat slab. Tempeh, the fermented patty. Each one delivers more usable protein than the meat it replaces. Each one corrects a mistake the supplement aisle has profited from for 40 years. Each one reaches the body within 2 to 3 weeks of daily inclusion. Strength sat in the pantry the whole time. The bag of lentils, the handful of seeds, the patty wrapped in leaves. The supplement aisle did not lose the protein. The kitchen forgot how to open it. For the household willing to relearn the small kitchen techniques, the soak, the sprout, the ferment, the honest spoonful, strength returns on its own. Never from a prescription, never from a powder, never from $1 more than the dried bag already costs. Picture a morning, 3 months from now. The pickle jar opens on the first turn. The legs carry the body up the stairs without complaint. The man who could not loosen the lid is no longer that man. The kitchen quietly took back what the grocery aisle convinced him he had lost. Which of these 8 plants already lives in the pantry of the household watching this, and which will be the first to reach the table this week? Pass this to the friend, the brother, the neighbour over 55, who has been quietly losing strength and wondering why. The kitchen knowledge that fed grandparents to 90 did not vanish. It was set aside. Setting it back on the table is the smallest act of rebuilding a body and the largest act of returning a tradition.